Hello, student. Today I will discuss the Kirchhoff's law, and on this one, Kirchhoff's voltage law. To understand this idea a little more, let's look a single circuit loop. Here is the single circuit loop, and the single circuit loop is A, B, C, D. I am informing you that we are taking a very simple circuit so that you may use this circuit in other complex circuit also. In this loop, the current from the cell is I. This is source cell. It is represented by Vs here, and the current is I. The first appliance is the resistance. The current flow from higher to lower voltage. So this side is at higher level, and this side is at lower level. I draw here the bars to represent their voltage level. So what happened here? The voltage is falling down. The next resistance is R2, and here is a higher potential level, and here is a lower potential level because current is flowing from higher potential to lower potential. So the bar size is longer for higher potential and shorter for lower potential. So again, the voltage is coming down. So there are two appliances here, R1 and R2. Let us say we have a third appliance. It is R3. Then the current is flowing in this direction from C to D. So this point is at higher potential level, and this end is at lower potential level. The bar is at higher potential is longer and at shorter at lower level. So the potential is falling like this. Now to take the Kirchhoff's voltage law, which states that the algebraic sum of the voltage, that is sigma V, is equal to 0 on a complete loop, right? Now we will find out the equation using Kirchhoff's voltage law for this loop. The loop is A, B, C, D, and we are taking the clockwise direction for making the equation. Now starting from point A, the appliance is R1, so voltage across R1 is I R1, right? And the current is coming from higher voltage to lower voltage level. So the sign will be negative. The second appliance is R2. Again, the current is flowing from higher to lower level, and we are going from B to C. That is from high potential to lower potential end. So it is negative I R2. For third appliance, when we passes the loop from C to D, the appliance is R3. The current is again I. So it is again coming from higher potential level to lower potential level, higher to lower. So higher to lower level. So it is again negative I R3 is the potential between C and D. Now we are coming here at point A, D, and moving for the loop D to A. D to A to complete the loop. So the appliance is the voltage appliance, that is the source, and the potential at this point is lower, at this point is higher, and we are moving from lower potential end to higher potential end. So it is plus V source, and it is equal to 0 as we reach at point A. Now we may write this equation as Vs is equal to I R1. It is equal to I R1 plus I R2 plus I R3. So Vs is equal to I R1 plus R2 plus R3. If we divide both sides by I, Vs by I is equal to R1 plus R2 plus R3. What is Vs by I? Voltage upon current is resistance from Ohm's law, and this resistance is equivalent resistance of circuit, and in this time the resistances R1, R2, R3 are used in series, so it is equivalent resistance Rs in series is equal to R1 plus R2 plus R3. So the Kirchhoff's voltage law is verifying the law of resistance in series. Rs is equal to R1 plus R2 plus R3. If other resistances, then they will be plus R4, R5, and so on. Now we take some other circuit. that here is another circuit, and in the circuit we are again using a simple one, not a complex circuit, but here is the numerical. The supply voltage V is of 12 volt. The current is coming on them is 0.2 ampere. The first resistance is 10 ohm. Then the voltage will be 0.2 into 10, that is 2 volt. Now 0.2 ampere is coming here on 20 ohm. The resistance will be 0.2 into 20, that is 4 volt. And if the current on this one is coming here, the current is 0.2 and resistance is 30 ohm. Then it is 0.2 into 30, that is 6 volt. Now let us say here we do not know the value of current. We don't know this value. Then what we use here? We will use here current I, which is coming on this resistance, then this resistance, then resistance R3. It means we don't know the current I, so we don't know the voltage also. We are assuming here that this current comes 0.2 ampere in our answer, yes or not. We are taking Kirchhoff's law here for loop A, B, C, D, A. Starting from point A, the current is I, appliance is 10 ohm, and we are going from the loop ABCD in clockwise direction. So the voltage across R1 is I into 10, and the sign is negative because we are coming from higher voltage to lower voltage end. We are moving in the loop clockwise. Then again minus I into 20. Again the current is I and resistance is 30, higher to lower potential end. So it is minus I into 30. Then we move from D to A, appliances source voltage, and the source voltage we are moving in clockwise direction from lower side to upper side of the voltage. So it is plus 12 is equal to 0. So 12 is equal to 10i, 20i, 30i, that is 60i minus 60i, and on other side it will goes, it is plus 60i. So I is equal to 12 by 60, that is equal to 0.2 ampere, which is proving the circuit is correct. We are using the correct Kirchhoff's voltage law. So voltage across R1, the first resistance is equal to I R1, that is 0.2 into 10 ohm, so it is 2 volt. Similarly, V2 0.2 into R2, R2 is 20, so it is equal to 4 volt. V3 0.2 into resistance, that is 30 ohm, so it is equal to 6 volt, right? So this is a simple way how we use the Kirchhoff's voltage law in a circuit. Let us try an equation for another circuit. Now let us take here a circuit like this one. Here is a cell or battery. It is providing potential difference V, and here is a resistance R1, a resistance R2, a resistance R3, then what will be the relation using the Kirchhoff's voltage law? You know these resistances are in parallel. So the parallel resistance, you know the equivalent resistance is 1 by R1 plus 1 by R2, 1 by R3 is equal to 1 by R equivalent resistance in parallel. Let us try here. Here is the current I, which is coming from the source, and it is coming here. Now here the current is through R1 resistance is I1, because now current is distributing here. The current on R2 is I2, and the current on R3 is R3, I3. The current is distributed from this point. These all points are same because they are joined by a single line. So here is R1. The current on this one is R2. The current on third one is R3, I3. So the current are I1, I2, I3. Now let us say here we have the loop point A, B, C, D, E, F, G, H. Now we have loops. The first loop we are taking as A, B, G, H, A. A, B, G, H, A. The direction is we are moving in anti-clockwise here, like this one. Starting from point A, the first appliance comes R1, and the current move from higher to lower potential end, so it is minus I1 R1 is the voltage across it. Then we reach here G, H, and then we coming from S to A. The appliance is V, and we are moving from lower voltage to higher voltage at this time. So it is plus V is equal to 0. So V is equal to I1 R1, or I1 is equal to V by R1. In next loop, we taking loop A, C, F, H, A, A, C, F, H, A. Then it will be minus I2, R2, because from coming from A, the appliance is R2, higher to lower potential end, minus I2, R2. Then we reach F, then we reach H, then we reach A, passing through the appliance V. So it is plus V is equal to 0, or I2 is equal to V by R2. The third loop we may consider here A, D, E, H, A. The current on this one is from, if we coming from A, the first one is point A, D, appliance is R3. We are coming from higher potential to lower potential. The voltage fall on them is minus I3 R3 plus V. Again in same pattern. When we move S to A, it is plus V is equal to 0. So I3 is equal to V by R3. Now we have the point B. At point B, we are using Kirchhoff's current law, the first one, at point B. The current from B is I1 leaving, I2 leaving, I3 is also leaving. And the incoming current at B is I, this one. This I current is coming from A to B. So we will have the Kirchhoff's current law. The incoming current is I, and leaving current is minus I1 minus I2 minus I3, as they are leaving from point B, and the algebraic sum is equal to 0. So we can write I is equal to I1 plus I2 plus I3. Right? I is equal to I1 plus I2 plus I3. So I is equal to I1 we know from this equation It is Vy R1 plus I2 is Vy R2 plus I3 is Vy R3, right? Then we know I is equal to Vy R. What is R? R is equivalent resistance in parallel. So I is equal to V by R parallel is equal to V by R1 plus V by R2 plus V by R3. If we divide the equation by V, what we will get? 1 by R parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, using Kirchhoff's voltage law, we find out the equivalent resistance in the circuit, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. On this way, we may use the Kirchhoff's law in various circuits. You may take other loops also, like B, G, F, C, B. B, G, F, C, B. What we will get on B, G, F, C, B. If you move like this one, starting from B, higher to lower potential and the current is going, so it is minus I1 R1. Now it is current is coming from higher to lower, but we are moving from lower to higher end, so it is plus I2 R2, and now we reach here at point B, so it is equal to 0. So we have another equation, I2 R2 minus I1 R1 is equal to 0. By this way, we may get various equations in various loops. That's all today. We will take use of Kirchhoff's law in various instrument also and various circuit also. Thank you.